So today we're actually going to make the graphs of these rational functions. So we'll go through all of the steps that we learned last time on how to find the asymptotes and everything, and then we'll throw that on a graph. The first thing I like to do is factor on the top and the bottom if I can. And then I'm going to save looking for symmetry until after I find the other things. It might not even be necessary. To find the y-intercept, remember that we always set x equal to 0. So we'll put a 0 in for x. And then for the x-intercept, that happens when the y value is 0. So we set the entire function equal to 0. The only way that a fraction is going to be equal to 0 is if the top is equal to 0. In other words, I can multiply both sides by x squared minus 9. And really I'm just looking for where 2x squared, just where the numerator equals 0. Divide by 2, take a square root, we still just get 0. Our vertical asymptotes pop up at -3 and 3. At the values that make the denominator 0. I don't have any factors on the top and bottom that match, so there are no holes. And then to find the horizontal asymptote, we just look at the leading term on the top compared to the leading term on the bottom. This time this reduces just to the number 2. So my horizontal asymptote is y equals 2. As far as symmetry, I am seeing some symmetry. Where I see a 3, I see a -3. And the zeros mean that I could have origin symmetry or y-axis symmetry. So let's check that out. So to check again for y-axis symmetry, we're going to plug in a -x. And we know that -x squared is the same thing as just x squared. And so you notice that this is the same function as the original, so this must have y-axis symmetry. As far as additional values, it kind of just depends on the graph. So why don't we get all of this stuff on the graph and we'll see what additional values we might need. My x and my y-intercept are the same point, the point 0, 0. I've got vertical asymptotes at -3 and 3. My horizontal asymptote at y equals 2. And that's really all I have, other than that there should be y-axis symmetry, but otherwise I don't know if I'm expecting maybe the graphs to be up here, or maybe they'll be down here. And for what's happening in the middle, I might have sort of an upward facing u, or it could go downward. That would be y-axis symmetry. So what we need to do is we need to plug in a few additional values. So you want to pick some x values that are on either side of the vertical asymptotes. So I think I'm going to choose -4 and -2, and then really 2 and 4 should have the same y value, right, because of the symmetry. So let's try plugging in a 2 and a 4 and a -2 and a -4 just into the function. So we're going to take that 2x squared over x squared minus 9. I got -1.6, so I should also get -1.6 at -2. And then plugging in a 4. This comes out to like maybe 4.6-ish, so the -4 should have the same value because of the symmetry. And I will just plot all of those points on the graph and see what it's looking like. Now for me, that's enough points. If you think you would like a few more, go ahead and put some more in the table. But knowing that I have a point, let's say up here, I know that I can follow that vertical asymptote and this horizontal asymptote to make what looks like a rational function to me. Then same thing on the other side with the symmetry. And then between the asymptotes, it looks like it's a downward facing. And this is not a parabola because it's getting closer to those asymptotes. Remember, parabolas are infinitely wide, but it is U-shaped, upside down. And so we just use the 7-step strategy for graphing a rational function. We're going to try one more just to practice all of that. I like to start by factoring. Skipping the symmetry for now. Remember that a y-intercept is where that x equals 0. Y-intercept at 3/4. X-intercept happens where y equals 0. I'm going to use the factored form for this because remember, I'm really just looking for where the top of the fraction equals 0. That's the only way that a fraction can equal 0 is if the top equals 0. And I know that the top will equal 0 at -3 and +2. But you know that +2 isn't even in the domain, right? If I stuck in a 2, I would get 0 over 0. And that's not going to work out. So really, my only x-intercept comes from this factor, the -3. Our vertical asymptote, we're going to check where those bottom factors are equal to 0. So I know at x equals -4, I'd have a vertical asymptote. And then this x equals 2, again, since we have those top and bottom factors matching, that's actually where our hole will show up at x equals 2. And then the horizontal asymptote, taking the leading term over the leading term from the original, that simplifies to 1. So we have a horizontal asymptote of y equals 1. This time I'm not seeing any sort of symmetry because if there was a vertical asymptote at -4, there should also be one at +4 for either type of symmetry. So if you see any mismatches on those x's or the x-intercepts, vertical asymptote holes, you can just say that there isn't symmetry. Now when I say no symmetry, I mean no y-axis or origin symmetry. So then we can go ahead and put our y-intercept and our x-intercept, our vertical asymptote. I'll have to keep in mind that there's a hole at 2, and just remember to put a stop in that graph. We've got a horizontal asymptote of 1. And it looks like I can already tell what's happening over in this section of the graph, right? It's going to be following down the vertical asymptote and coming over here. Remember that there's a hole at 2, so we'll just kind of skip over 2 as we go towards that horizontal asymptote. I am going to need some additional values because I'm not sure if the other piece will be right here or whether it'll be right here. But I know something's happening over there, so I might just stick in a -5 and find out if it's high or low. And you can put that into the factored version or the unfactored, up to you. (14 over 7), so 2. So I've got a point right here, which tells me that I'm going to be following sort of this quadrant over here, following those asymptotes just like that. And so that's using that 7-step strategy for graphing your rational functions. Go through and find all the good stuff, throw it on a graph, find a few extra values if you need to, and then just trust those asymptotes.